All right, our home plate for tonight is only 8 problems. Bam. And it's rewrite the function if possible and graph. It says identify domain and range. And for tonight's home plate, for the purpose of it, for the domain and the range, I do want to see domain and range for numbers 1, 2, 3, and 4. For the last 4, you don't have to identify domain and range, just for the first 4. Number 1 reads g of x equals 6x minus 1 over 2x plus 2. Number 2 is g of x equals 1 over x squared minus 49, and then minus 3 for the whole thing. Number 3, g of x equals 1 over x squared minus 16, and then at the end plus 2. Number 4 is g of x equals 1 over x squared minus 12. Bless you. Number 5, g of x equals x squared plus 4x plus 3 over x minus 2. Number 6, g of x equals x squared minus 7x plus 10 over x plus 1. Number 7, g of x equals x squared minus 3x plus 2 over x plus 4. And number 8, g of x equals x squared plus 2x plus 1 over x plus 6. So it's only 8 little problems. Only. And our objective, we're still on the same objective. Our objective for today, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. Okay? So, do we need a fair model for rational functions? No, you already know what the definition is, yes? So you know the definition for rational functions? All right, very good. Rational functions are equations with a rational expression, at least one rational expression. Okay, equations with rational expressions. All right, and I gave you guys processes. We already have the steps, is that correct? I gave you 4 steps for graphing and 5 steps for writing a function given a graph. And last night you had 2 of those practice problems from the book, right? Then I gave you 6 problems for you to do in regards to rewriting and graphing. All right? So, quick recap. You guys remember the general rule for transformations? Yes? Yeah, we went from here to here because of the rationals. And what do we say H and K were now for rationals? They were asymptotes. And we've been working with what? Vertical and horizontal. So today we get to the funner ones, which are the oblique, slant, or diagonal asymptotes. Good thing you did your practice, right? Damn. Vertical asymptotes, horizontal asymptotes. Okay, we did some of these. We went from there to these. We needed to rewrite it to look like that. Yes? So we went from there to there, to there, to there, to there. Piece of cake? Yeah. From there I gave you guys a graph, and you needed to write a function given the graph. And the process, we used those 5 steps. Then we did something like this, like that, and then we got to these. And what did we say this was? A quadratic. And then the graph was here and here. You guys remember that? Then we did some of these. Some of this, yes. But we cannot have a negative on the numerator, so where does the negative go? In the front. This one, we cannot have a negative 2 in the numerator. What can only stay in the numerator? A 1. So what goes in the front? Negative 2 times the whole thing, yes? And then this changes. Is that correct? Okay, good. Let's do this one together. Example 3, super duper Q. 3 super duper Q, it says rewrite the function and graph, identify domain and range, and it reads g of x equals 4 over x squared minus 6x plus 9 plus 5. For the purpose of just reviewing, we're not going to graph that. We're just going to rewrite it, and we're going to identify the asymptotes. Here we go. This needs to look like this. G of x equals fraction with a 1 on the numerator, parentheses denominator to the second power, and we need a constant. Is that correct? So what can we use from here already to write it over here? The 5, that is correct. It goes right there. How about the 4? We took away the 4 and we put a 1 because 4 is what? 4 times 1. So if we left the 1, where does the 4 go? In the front. 4 times. Okay. So how do we find the factors of this? There it is. Factors of 9 that add up to negative 6. Negative 3 times negative 3. That gives us 9, and if we add those, it's negative 6. So my factors are x minus 3, x minus 3, and what's another way of writing that? X minus 3 squared. And of course from there we can actually get our vertical asymptote, x equals 3, which is right there. Horizontal asymptote, y equals 5, which is right there. Piece of cake? Yeah? All right. Do this one on your own. G of x equals 7 over x squared plus 4x plus 4 minus 3. Rewrite that. You got 20 seconds. All right, give your neighbor the function already transformed. What does it look like? All right, g of x, I heard g of x equals 7 times 1 over x plus 2 minus 3. Hands, have you got that? Yeah. And once again, how do we get x plus 2? Well, you need to factor the denominator. 2 times 2, x plus 2, x plus 2, and we rewrite it like that. Okay? Show me over here, I'll come to you all with those. Yeah, we got this, yes? Yes, I see you window, please. All right, good. Shall we crank it up? Ha, ha, ha. Copy this one. Example 4. Example 4 reads, rewrite the function and graph. Identify the domain and range. Okay, just copy it. I'm going to go over this one. Okay, because it's a little bit different. You might think it's the same and you already jumped the gun, and no. It has something very particularly different. Ready? Look up to the screen. Write your utensils down. Here it goes. I'm going to zoom in. What is obvious the same? The 1. What else is the same? The constant at the end. What looks a little bit different? The denominator. Notice that it's not in parentheses and the whole thing is not squared. So we can assume that from here we can get our horizontal asymptote, which is y equals what? 3. Okay, so that one's the easy one. Okay. However, look at this. How can we factor that? What's that? It's a difference of squares, but aren't we going to end up with two factors? So, what's another way of finding our vertical asymptote? What did we practice before we did anything? We did what? Excluded value. So what do? X squared minus 36 equals 0. What do? Plus 36 plus 36. X squared equals 36. Square root, cancel that squared. We're left with X equals plus minus 6. You're like, what? Yes, now we have X equals 6 and X equals negative 6. Copy that, please. All right, I'm going to zoom out. I'm going to move these out of the way. Okay, so I'm going to plot the horizontal asymptote first. That is 3 of y, which is right third. Okay. Then I'm going to plot the vertical asymptotes at negative 6. Positive 6. All right. Now check this out. What kind of graph did we get when we were doing squares? We had this, and we had that. Can you guys see it? Yeah? You're like, Mr. Q, but why is there such a huge gap here in between? Because in between we're going to do this. Copy that. You're like, why is it like that, Mr. Q? Because if I was to ask you to build an input-output table and give me points, guess what's going to give us? It's going to give us that inverted parabola like that. So what can we conclude whenever we don't have a factor squared down here, but it's two terms like so, that we're going to end up with two vertical asymptotes, one horizontal, and this is going to split up like so with this in between. That will always be like that. Anything else, it's just a transformation. It's going to move it around. Yes? Did you ever hear that one? So if this was negative, what would it do, everyone? Yeah? Yeah, we'll flip. All right, do another one. See how you do with this one by yourself? Ready? Example 4Q. Example 4Q reads, g of x equals 1 over x squared minus 64 minus 5. Find me the horizontal asymptote, the vertical asymptote, and graph your function. I'll give you some time. Copy and. All right. Horizontal asymptote, y equals negative 5, and vertical asymptotes, 8 and negative 8. Hands if you got those. All right. So to graph it, I'm going to get rid of my coordinate plane because it's not going to fit here, and I'm going to make a generic one, but yours, it does fit on your graph, right? Here it goes. Oh. We got negative 8, positive 8, our horizontal is at negative 5 down here. And our graph should be right there. right there, and right there. Hands if you got that? Yeah, we got it, yes? Show me what I'm talking about with this. Yeah, we got it. Okay? Now, let's talk about domain and range, because this is like the first four of the home plate, yes? Domain and range. Domain. And I wanted an interval. So check this out. This arrow, look up, this arrow is pointing to the left. Is that correct? That means the x values are going to be going all the way to negative infinity. This arrow is pointing to the right, which means it's going to go to what? Positive infinity. But also, do we include the values for this graph? Yes, everything in between. Which are the only x values we exclude? Negative 8 and 8. Therefore, I'm going to write my domain from here to here, from here to here, and from here to here. Ready? From negative infinity to negative 8. Union from negative 8 to what? Positive 8. Union from positive 8 to what? Positive infinity. They're like, what, Mr. Q? Yeah, so watch. We're doing domain for this portion, domain for this portion, and domain for that. And we're just doing what? Unions in between. Does that make sense? Yes, Mr. Q. All right, good. Next, range. Range. If we read it from the bottom to the top, who notices that this arrow keeps going downward? These two, so it goes to what? Negative infinity. These arrows up here keep going upward to what? Positive infinity. So for my y values, we go from negative infinity to what? Positive infinity. So what's the only y value that's excluded? This one right here, which is negative 5. So my range is going to go from here to here and from here to there. So it should read negative infinity, comma, negative 5, union, what else? Negative 5 to positive infinity. We good? All right. Let's crank it up a notch, yeah? Copy this one, example 4 super cube. G of x equals 1 over x squared minus 5 plus 1. We're going to do this one together. Here we go. To get us started, our horizontal asymptote is y equals 1. Okay. To get our vertical asymptote, what do? X squared minus 5 equals 0. Then what? Plus 5 plus 5. X squared equals 5. Square root, x equals, wait a minute, Mr. Q. What is square root of 5? We can find the decimal. Let's go. Good thing we did all that practice in the warm-ups and stuff, right? So let's see. Square root of 5. Between what two perfect squared numbers is 5 found? Very neighbor. 4 and 9. That is correct. So I take the smallest one, square root of that is 2, and I need a decimal form for the rest. How do I find the rest, Mr. Q? Here it goes. The middle minus a small, that gives me 1, over the large minus the small. That gives me what? 5. So, do we know how to find that decimal form? Let's see. 1 divided by 5 does not fit. It's in there twice. So this is 2.2. Is it exact? No, it's approximately. All right, let's plot those asymptotes. 2.2 is about right there, approximately. Negative 2.2 is approximately right there. And our horizontal asymptote is y equals 1. So our graph should be right here. How we doing? Show me your parents, I'll come to you out with this. Okay. You want to try one by yourself? Okay, good. Example 4 mega cube. G of x equals 1 over x squared minus 30 minus 6. Find me the asymptotes and graph the function. Copy that and go. There's the work. And if you got y equals negative 6 for our horizontal, vertical approximately 5.45. Some of you rounded to 5.5. That's fine, I guess, since we're doing approximations. All right, so 5.5 or 5.45 is about right there. Negative 5.5 or 5.45 is approximately there. Negative 6, oh, let me move this out of the way. Negative 6 is right there. So my function is right there. And we got that by yourself? Okay, good. You got this, yes? Well, hopefully you have one of these with approximation, but the rest are just straightforward blah, blah, blah. However, let's crank it up a notch. Boom. Or should I say, a bam. Let's go. Example number 5. Ha, 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 ha. Example number 5 reads, rewrite the function and graph, identify the domain and range. For these, don't worry about the domain and range, I just want to see the graph. So, g of x equals x squared plus 5x plus 6 over x plus 1. Just copy that, I'm going to go over the whole thing, okay? All right. Once again, g of x equals x squared plus 5x plus 6 over x plus 1. What is the first thing you notice? We no longer have a 1 on the numerator. Now we have a quadratic trinomial. However, does the denominator look familiar? Yes, which means we can actually get our vertical asymptote, which is x equals what, everyone? Negative 1. Okay, I got that down. How, Mr. Q? Because we can set this equal to 0, solve, and that's how we get x equals negative 1. Okay. However, we still have a dilemma. We don't know what to do with that. So write your utensils down, look up to the screen. I'm going to zoom in. Stay focused, please. Here we go. Whenever you have a function that looks like this, whenever you have an x squared on the numerator and a regular x on the denominator, notice that the power difference is only 1. You guys notice that? This is to the second, this is to the first. This graph will always work for these kind of situations. Let me show you how to get the graph. We have one asymptote. There it is. Let me show you the second one. X squared plus 5x plus 6 divided by x plus 1. What number times x gives us x squared? X. X times x, x squared. X times 1 is 1x. I'm going to subtract. What does that mean? I distribute that. This is a negative and this is a negative. This cancels. I'm left with 4x. Bring down the next term. What number times x gives me 4x? 4. 4 times x is 4x. 4 times 1 is 4. I'm going to subtract again, which makes this a negative, and this is a negative. We're left with 2. For the purpose of getting the asymptote, I no longer worry about the remainder or anything else. The only thing I need, pay attention to this part, is the quotient. This is what we call a slant asymptote. Or in other words, an oblique asymptote. And how do I write it? Check this out. Y equals x plus 4. Copy that, and I'll show you how that looks. So let me zoom out. Check this out. I'm going to start with my vertical asymptote. It's at x negative 1, which is here. Okay. Now let me show you the slant asymptote. Do we know how to graph this? Yeah, we start at what? Positive 4, which is right there. What is my slope? 1, which is 1 over 1. That means one step up, one to the right. Plot your point. Do it again. One step up, one to the right. Plot your point. Do it again. One step up, one to the right. Plot your point. Do it again. Then we can go the other way. One step down, one to the left. Plot your point. Do it again. There it is. And then make it a dash or dotted line. This is what we call a slant asymptote, or in other words, an oblique, also known as a diagonal asymptote. So from now on, I'm going to label it like this. Look up. SA. What does SA stand for? Slant asymptote. Okay. And here goes the graph. Look up. Bless you. Copy that. You're like, that's it? That's it. For this one, don't worry about the domain and range right now. I just want you to understand the graph and where it's located and how to get the asymptotes. So, everybody copy this. All right? Let's do another one. Here we go. You do this one, next one by yourself. The process, once again, to get the vertical asymptote, we just set this equal to 0, or we can obviously see that it's negative 1. But to get the slant asymptote, what do? Long division. Is that correct? And we just focus on the quotient. Here it is, example 5 cubed. We got q of x equals x squared plus 5x plus 4 over x minus 3. And down here, I'm leaving this first step that says use long division to rewrite. So I'm just going to leave it there. Copy that and go. See if you can graph that. Okay. We got for our slant asymptote y equals x plus 8. Yeah. And for our vertical, x equals 3. And how does that look in a graph? Let's see. Positive 3, which is right there. Positive 8 is up here. And then it's 1 over 1. That means 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right. Oh, it's a vertical. My bad. Sorry. Yeah, I did that to see if you were paying attention. Thank you. Vertical asymptote, 3. And where's my graph? Right there and right there. Hands, have you got that? Yeah, show me your parents how comfortable you are with these also. Yeah, we got these, yes? All right. So once again, our home play for tonight, not Fortnite, is these 8. Make sure you work on those. Make it a family math night. Enjoy. See you guys tomorrow. Bye.